Hello and welcome to the Code Mavens meeting, the presentation about continuous integration or CI for Perl projects and specifically GitHub Actions for Perl projects. My name is Gabor Savo and I've been a long-term Perl programmer, and then for many years I've been programming also Python, and recently, more than a year, I've been writing Rust. So these are the three main languages that I work with. I have been self-employed for like 25 years now. I started programming about 40 years ago, but I've been self-employed for some 25 years. And most of the things that I do is teaching, both programming and various things around it, like Git. And one of the things that I really like to teach people and introduce to companies is test automation. And with that usually also comes setting up a CI system, a continuous integration system, so people will be able to run. So those tests that people run those tests that people write, they will actually also run automatically whenever they push out something to GitHub. The same way as we have GitHub Actions to run these CI tests on GitHub, we also have similar things for GitLab if you're using GitLab, and probably other of these Git hosting solutions. And there are other ways to do these things, so that's not just the only one. But if you're using GitHub anyway, then using GitHub Actions is a good idea. In this presentation, I will especially focus on Perl, even though GitHub Actions can do basically anything you want, any language. But our focus is going to be Perl project. So if you're doing some other language, if you're using some other language, you will still learn quite a lot from this, I hope. But the examples are going to be primarily about Perl. What else shall I say just for the beginning? As I mentioned just before the video, if you have any questions, just feel free to ask the question. And let me share the screen, and so I can talk about other things, and I can even show them. So yeah, the right button here, this one. So you're supposed to see now the website of the meetup. If you're not registered, then go to the Code Mavens group. So this is the name of our group, Code Mavens, where I'm running these meetups, meetings, presentations about those three languages. So it's Perl, Python, and Rust. And then most of them are recorded, or usually I try to record them. So if you're watching the YouTube video, then again, please register on that meetup page, so you get notified when our next meeting is. The advantage, of course, being in the meeting is that you can ask questions. And after the meeting, after recording, once everything is done, then I stop the recording, and then you can stay around and we can discuss other things about the topic off video. So in case you don't want to be part of the don't want it to be on the video, that's also fine. Just wait till the end, and then we can discuss things. You can even we can even stay around, and while you're trying out various things, and I can help you if you encounter some issues. So this is the meetup page. If we go to I think if you go to Code Mavens and YouTube, that will lead us to the channel, YouTube channel. I also listed, add it to the chat so people can follow it. So please follow this YouTube channel and then like the videos. If you're watching the video, then please start by liking the video and following the channel, the bell, and sort of, yeah, you know how to do this. So these are the administrative things. One more thing is that I think I have some links here, but I think Meetup, when I updated it last time, Meetup broke all of my links. Anyway, there are some links at the bottom of the page leading to the places like Patreon and GitHub sponsors, where people are sponsoring my work with a monthly payment. And I would like to thank them for enabling and allowing me to give these presentations free of charge. And I definitely also would like to thank all the soldiers who are fighting for us, so we can safely be at our home and work on computers and do what we need to do. Okay, so slides. I'm going to use quite a few slides, although in order to have some order in this presentation. So I'm going to share the link to the slides. The slides are public. You can get there any time. They are also in GitHub, the source of the slides, so you can get them too. So there are a couple of entries in this thing. We are going to cover or go over some part of the GitHub Actions part, which is the more generic discussion about GitHub Actions, and the GitHub Actions for Perl. After I moved there some of the items and started to try to enhance that. So let's start with this one, because I would like to talk a little bit about the goals, specifically for Perl, and then we get back to the more general introduction. So our goals is setting up some kind of a CI system, so continuous integration for CPAN modules in general, but in particularly for any even non-CPAN Perl code. And the code can be actually in either in public repository or private, it doesn't matter. GitHub, Microsoft basically, GitHub provides you this service free of charge to some extent. I think if now I need to go immediately, I can go to the other one as well, other slides, because there actually I have some links here. Yeah, so the first page leads to the pricing. So GitHub provides a certain amount of minutes of running your jobs per month. I don't know, 2,300 minutes. It's actually way more than enough for any of my needs. And beyond that, you might need to pay. But for me, it's I do pay some amount, but I don't think that I actually need to do that for my needs. Anyway, most of the stuff is free of charge, so that's fine. So these are the two main things: setting up some kind of a continuous integration, either for CPAN module or a non-CPAN Perl code, or in general for any code, basically. There's another sort of goal here is to set up something that can collect data, something that can run jobs on a scheduled base and then collect data, maybe generate a website. And actually, this part is mostly the content of the next presentation that I think we are going to have in some 10 days from now, if I remember correctly. We can actually get back here to the meetup group to see when is the next meeting about Perl. So this is this one, GitHub Pages. So it's on the 15th of August when we are going to talk specifically about GitHub Pages. But the basis of that is GitHub Actions. So that's why I have this collected data and generate website. That's more that area. So we'll see how much of that we can cover today and how much is going to be in the next meeting. Before I get actually to the GitHub Actions and GitHub workflows and all these things, I need to talk a little bit about CPAN testers, because every time I mention GitHub Actions on any of the Perl forums, and immediately people jump and say, oh, but there are CPAN testers, we don't need GitHub Actions, and what is. So let me say a few words about CPAN testers and then basically try to compare why you still would like to have GitHub Actions even though we have CPAN testers. So especially if you're not a Perl developer, a CPAN developer, then you're probably not familiar with this. CPAN testers, I think this is the leading to the main website of CPAN testers, which is not that attractive here. So let me close that. The interesting part would be, let's say this one, okay? I go to the DBI module, Perl module, on the MetaCPAN website. So if you're not Perl developer, this is like the PyPI website, or everything collected here, okay? So this is one of the Perl extensions, the DBI, the database interface. And on the left-hand side, but it's true for every CPAN module, on the left-hand side, you will see testers and some numbers here. So if you click on that one, on this link, you will get to the to the cpan testers, the matrix page of the cpan websters. And there are some errors, unfortunately, here from the website, but the data is what is interesting. So what happens every time you upload? Someone is telling that I'm not sharing my screen, but I think I do share my screen. So it's strange that no one can see the share screen. Okay, so at least one person can see my share screen, another person too. Okay, so Jim, that you can't see the screen, that's I don't know why. Okay, I'm talking about the cpan testers matrix. Okay, thank you for the feedback. Okay, sorry, Jim, I don't know how to fix it. It seems that most of the other people do see my screen. So I'll try to smile at least. Okay, what can I say? Sorry. So this thing, what happens is whenever someone uploads a new version of a Perl module to cpan, then some people who configured their machines to test these things, they immediately or within a few hours or days, they download the newest version, run all the tests that come with this distribution, and send back the data to this central database. And so here you can see the reports from the various of these volunteer machines. Volunteer people is their volunteer machines on the different versions of Perl, on different operating systems, and if the tests that come with the module, with the distribution, if they passed. And as you can see in this case, most of the services, most of the systems report that all the tests are passing. Some, the red ones, say that some are failing. So this is a sort of a CI system, and it was basically the state-of-the-art CI system that existed, I guess, 25 years ago when this all started. But things improved since then in general open source world. And it's especially useful for all the other languages that don't have this feature. But we can also use those services for Perl, and we can improve our feedback loop by this. So this is an excellent service, but it's based on volunteers sharing their computers, or people who use your module. If they configure their system, then when they are installing your library, your distribution, then they will also send in this report into the central server. And you can find this next to each distribution. So this one has 8,000 or so success reports, 186 failure reports, and 4, I don't know what is this, something else. Okay, doesn't really matter. Okay, so that's an excellent thing, but there are a couple of limitations of this. First of all, this only runs for cpan modules. So if your code if you don't upload it to cpan, maybe because it's private, or if it's not something, a library that you would want to share, but maybe it's an end user project, then you will never use this. You will never get the reports from the cpan testers. That's one drawback or whatever limitation. The other one is that this comes after you upload your code. So you might be developing your next version for a couple of weeks, and only when you release this version, or you release a beta version of it, only then a few days later, or a few hours or a few days later, will you get the report. In addition, some of these systems will not test every distribution. For example, let's see this one, because I'm going to talk about, actually I'm going to show the testing of this DBDPG, which is the Postgres driver, database driver. And actually I think I can see the testers having some reports, not as much as for the DBI library, but they have. But I'm not sure that they ran all the tests. You see, for the DBI, you don't need any database to run the tests, because it comes with I think it will run with SQLite and run the tests that way. But for Postgres, in order to really run the test, you need a you either run only the tests that don't need a database server, so only the external tests, but for some of the tests, you actually need to set up a Postgres database and then test it with that. And I'm quite almost sure, I'm not 100%, I haven't checked it, but I'm almost sure that none of these systems actually have a Postgres database running. So they are testing only the part that doesn't need any database server for it, which not all the tests. If you're using GitHub Actions, then first of all, you will be able to run your tests on every push. So you make a little change, you push out your code to GitHub, and the tests will run, or anything you configure. So it's not just the test. Whatever you configure will run there. You can configure a database, a Postgres database, any version of Postgres basically, and then start it, and then you can run your tests while that server is running. So you can test all the tests that require an actual database there. And it's not just Postgres, of course. You can basically run anything that can have a Docker image, because you're running these things in Docker containers. So you can get feedback basically immediately, and not just a couple of hours or days after you release. Much more frequent feedback will improve the shorter feedback loop. That's what our goal is, or not, or tool is. Okay, the goal is to have bug-free code, but having faster feedback means that we can fix our code faster and so on. And you can set up basically any environment, any environment. Now, maybe they don't support the Solaris, and I don't know actually what operating systems they support beyond Linux, Windows, and Mac OS. So maybe I don't know if you can run FreeBSD, for example, or NetBSD or Solaris or these things. Probably you can do something. I've never tried it. But within those limitations, you can set up all kind of strange configurations. Okay, so that's about cpan testers and what might be the advantage of having GitHub Actions. Let me check if I can go over the general thing here. So to understand what GitHub Actions is, basically you create a configuration file that describes in what environment you would like to set up. So you would like a Linux machine or a Windows machine or whatever, or Docker containers, and then you configure some executables that can be, if it's not Perl, or that can be something that you would like to compile some code or just run some tests or whatever. Doesn't really matter, just any code you can run. And you have this configuration file. Whenever you have some event, so that could be some kind of a trigger, okay? And that could be, the basic one would be pushing out some new code. Then GitHub will notice that, will start a virtual private server basically for you within your configuration definitions, or it will start several of them, depending on how you configured, run your code, collect all the data, and then shut down the machine and send you a report, especially if it's failing. Okay, that's basically the thing. And you can do anything there. So you can set up a continuous integration, basically meaning that every push you run all of your tests or some of your tests or whatever. You can set it up that to run these things on every pull request. So whenever someone sends you a pull request, these things, okay, these tests, let's say, will all run, and then even without you actually looking at the code, the other person, the person who's sending you the pull request, can already know if their change broke any of the tests, and that can reduce their feedback loop or shrink their feedback loop and make it, and then they can fix things before even you look at the code. And obviously, you can see that, okay, the tests are passing or not, and if you're not passing, then you can already You don't need to reject, but you can comment on that if that's needed. You can also use it for continuous delivery or deployment, that the CD part, but that's we're not going to cover it. You need to some extra for that to obviously to deploy somewhere these things. You can set up scheduled jobs. Okay, so that's for we're going to talk a little bit about triggers, scheduled jobs. So this can be used, for example, to collect data. For example, you might be familiar with the Perl Planetarium, which is an RSS feed collector. This is running this way. So it's every, I don't know, hour or so, collects the data, and generates this website. And that's Dave Cross running, but I have a couple of other of these things that are running, collecting data and generating some website or whatever. That's the generating static website part. You can also configure these jobs to automatically handle, let's say, issues or pull requests. Okay, so for example, you can set up a job that will, let's say, close every issue that hasn't been commented on, that hasn't seen any action for more than 2 years, let's say. Okay, whatever. So you can do all kinds of these actions beyond just doing this code. Now, going back to the schedule, one more thing that I just remembered, that I think that Git can be useful. So let's say you have a project that you don't update too often, right? But you know that your dependency, and you didn't fix exactly the dependencies because it's a library, and in these libraries, usually you just set the minimum version of the dependencies, and you're just the immediate dependencies. So you don't have the full dependency tree logged in specific versions, because that's how you usually do with libraries. But those libraries all change, even though your project might not. So you might want to set up a scheduled job that runs, let's say, once a day or once a week, and runs all your tests with the most recent version of all of your dependencies. Okay, so you will get some notification as soon as some of your dependencies is released that makes your tests fail. Okay, and then you can do something with this. Okay, you can manually then open an issue on their repository or on your repository, or fix the issue or whatever. But you get this notification not a month or 2 months after they released something that broke your code, but or your tests, but immediately. So that can be also a very useful thing with a scheduled job. Here in this one, you have some link to the GitHub Actions documentation. Okay, so you can go there. There are tons of documentation about the GitHub Actions. And so that's how we get to the setup. So there are two, wait a second, okay, so let's go here and see one way to set up. So you can go to GitHub, let's say create a new project, new repository. I'm just going to create a new repository. I'm going to call it demo, fine. I'm going to create it with a README file, so there will be some content in it, and I won't have to deal with that. Okay, so now I have a totally new repository. I don't have anything in there. I can go to the UI. Let me enlarge the font a little bit, to the actions. Okay, so here are the GitHub actions. And then GitHub provides me tons of different setups, default or I don't know how shall I call them, default setups for various languages and technologies and whatnot. Unfortunately, I couldn't find anything for Perl. So I looked for it. There are 3 things that responded to my search. None of them seem to be about Perl. With Python, you will have better luck. So you have all kind of these workflows or GitHub actions, basically, that you can configure. So you can say, okay, configure. It will, I just picked one. It will show you the configuration file without committing it. And then you can either make some changes and then commit, or just commit it as right away. Now it's going to create a folder in your project called .github, in there a folder called workflows, and in there a file with some name, the name doesn't matter, .yaml. And I think you can both use YML and YAML for the file name, but these are the requirements. So basically, in this folder, you have one or more YAML files, and each one of them will be one of your GitHub actions / workflows. In a second, I'll explain. So this is a very easy to go and get started with some ready-made GitHub action from GitHub. So I could commit this and then it will start running. That would be one way to do this. I'm not going to do this because there's no point. There's no code in there, and I don't know if there is something interesting. The manual way, and here is described. The manual way is what I have in the previous slide, is creating this folder yourself and creating a YAML file that we are going to discuss what kind of YAML file. So there's nothing special that they do. They only just commit a file that was already prepared for this kind of workflow. And you can also create these YAML files and commit them and push them out, and then they will immediately work. So there are a couple of examples here. Let me show. Let's go over them. So this one is a very minimal YAML file that will run on Ubuntu. It has a name, a field called name with some text. Doesn't matter what the text is. It's just going to be the name of this workflow. It has a trigger. So this on thing tells you on what kind of event to run. In this case, push means that whenever this code is pushed out, this will run. Then you have several jobs. So this is a keyword. So name, on, and jobs are keywords. Inside, and it's a slightly strange, inside you can have various jobs. Now, in this case, the word build is a arbitrary name. It doesn't have to be build. You can put there test or kukuriku or whatever, any word you like, because this is a user-defined, user-selected name, basically. Despite the fact that it's a key in this YAML file, it can be anything there. Then comes the runs on. So here you have to tell what kind of operating system you would like to run on. We'll get to that, the various options there. Here we just said just the latest of Ubuntu, what they provide. So this is going to be run on some Ubuntu, and then you can have steps. So each one of these steps is basically some command on the Linux shell. So here this is just, and each step can have a name. I don't think that it's a requirement, but you can have a name. It's easier than to understand how it looks, what happens. And then you can have either a single command in this run field, or if you put a pipeline in YAML, that means you can have multiple lines in this field. Then you can have many of the commands, and you can see these are all just command line instructions in Ubuntu. Now, unfortunately, I didn't move out this example into an actual repository, so I can't show you the output of this, but we will have a few of them later. So this is the base. This was the basic for Linux. The basic for Windows, the difference is that I'm saying runs on Windows, and then the commands need to be things that can run on Windows. Okay, that's it. And the last one here is saying macOS latest, so this is going to run on some virtual private server running macOS. As I said, the name is some free text. The triggers can be something like push or push and pull request, and there are various ways to format them. So this one is, you can put a list like this, you can put a single element like this, a list like this, or you can put a list like this. So it's not a list anymore. It's a hash basically, but whatever. And then you can either say push and then you say nothing here, and that would mean every push, or you can say branches and you say which branches, or you can, the pull request, let's say, says that only on dev branch do this. So if there's a pull request on the dev branch, okay, whatever, I think it's rather random what I put here. Okay, there's also here it also have a scheduled job. So this is a regular cron tab configuration, basically meaning every 5 minutes run this job. And then here is the job, which doesn't really matter. Okay, just a simple job. Here we can have a link. You have a link to the documentation where all the events are described, and yes, other events. Okay. Strange. I thought that I'm going to have it. I put it somewhere here. Apparently not. Okay, whatever. There are more configurations of environment variable. Actually, this one I can show you. So you can both set your own environment variables, which are publicly readable like this. So you put this into the configuration file. You can also have secrets in GitHub Actions. So you go to your Git, let me go there, GitHub subgov demo. So you would go to the settings, I think, and then secrets and variables. No. Okay, I'm not sure. Actions, maybe actions here. No. Okay, whatever. Okay, I can't find it now. Anyway, you can set up secret values both per repository or per user, and then I lost the slides. Yeah, and then you will be able to access this information in your GitHub action. So you might need some password to connect to something, and that can be useful. There is now, in this one, I already moved it, so there is a demo for the environment variables. So this is just a plain repository with a plain README file, and here is the workflow, which just called CI, well, doesn't really matter. Here, what is interesting is that here you can see I set up an environment variable that will be true for the whole thing. Then there is an environment variable for this specific step. Okay, and then you can access this either as a shell thing. So here I'm just using shell, it's echoing out. Or if you're running some Perl code, then the regular way, yes, you would access some environment variable in Perl that can be done. The last thing you see here is that I'm going to print out all the environment variables that exist in this while this thing is running. Okay, and I'm sorting it out. Now let's go to the actions. And here is the output. So, okay, let me just go back for a second. So I click on actions, and you can see here, these were actually two pushes. The first one failed, so it's red, the job failed, and the second one was successful. So I click on it, and then here is the output of it. It's called build, the job, and that's why it's called build here. And these are the titles of the steps. So you can see first some setup. Okay, not that interesting. It's very generic. This is the first step where we are echoing the value of that environment variable. This is the second step, again, just echoing a variable. And this was the third step where we echoed out or printed out all the environment variable. As you can see, there are all kinds of environment variables, generic ones. But there are also a lot of them that start with GitHub. So these are environments that GitHub specifically sets for you. So you know that your whatever code you are running, that it runs in the GitHub environment, in the GitHub actions, and you can get all kind of information about it. What kind of event was it? It was a push event. I don't know who generated that event. I guess somewhere there is the SHA, the commit. Yeah, here.
Okay, so this was the commit. This is the workflow SHA, and this is the GitHub SHA. I don't know what's the difference. Okay, but you have all kind of these different environments variables that you can use. Okay, there's another thing called the matrix that you can set up various environments basically in the same job. So let's say you would like to run your tests on all or various versions of Perl. You can create a list of versions of Perl. You would like to test your Postgres with various database versions of Postgres. You create a list of these Postgres databases, and then basically you define matrix. You set up variable names. Okay, here we have two variables names: a fruit, apple and banana, and a meal, breakfast and lunch. And GitHub will run 4 jobs here. Okay, the apple, so the fruit will be apple, and the meal is breakfast. So all the combinations of these two variables. Okay, so in this case it's 2 times 2, 4 jobs. And I'm going to show you a version where I actually have this running in an environment. Okay, so this is a very useful thing. So we have set up this strategy, and then inside there is a matrix, and then inside the steps we can have these variables. So we will be able to know which version are we running right now. Okay, and based on that we can do all kind of configurations. Now, it also has another field called fail fast. The whole point is that these things are running. So you have like 4 jobs here, and you're limited, I think, to 3 jobs running in parallel by default. Actually, I'm not sure. I just tried it, and it ran a lot more for me, but I'm not sure why. So I think it's still 3, whatever. But you have a limited number of jobs that can run in parallel. So let's say 3. But here we have 4. So it's going to start 3, and then the 4th is waiting. And what happens if one of the 3 fails? So if the fail fast is true, that means that the 4th job won't run, and even the other ones will be shut down once it recognizes that one of them failed. If its fail fast is false, and I think that's the default, then it will run all the jobs even if some of them fails. And it's a trade-off, because if you run all the jobs, then it takes more time. Okay, it consumes more of the processing or the time that it might cost you eventually. On one hand, you get your feedback later if you're expecting the email, but you get all the feedback. If you have fail fast true, then the feedback is going to arrive much sooner. It's probably cheaper. But you don't get all the information, because maybe one failed, others would succeed, but you don't know that because they were all stopped in the middle. Here is the example. This one already moved out. So this is the parallel thing. Here I have 2 files actually. You can have as many files as you would like. The one of them is a matrix. So here I have a matrix with just version numbers 1 to 10. And you can see that I set the name of the job using that matrix variable. Okay, and then inside there is just something waiting there. And the CI YAML file, it has several jobs. So I have a job called test A. What did I do? I don't know. I clicked on something. So I have a job called test A, a job called test B. Okay, they are the same, but I copy pasted them. I had just several of these jobs, and each one have steps. And if we look at the actions, you will see that for the 2 files, we have 2 of these entries. So each file has an entry. And then you can see all of them here. And if I go and I think I can run this from here. This one is with the test 10 in the matrix, and I can say here, here, I can rerun all the jobs. So I can rerun all the jobs, And as they're waiting for like 10 seconds. So it says that they are all waiting, basically. And now they are all seems to be running for some reason. It surprised me, maybe because in this account I pay that $4 a month. Maybe I get more jobs running in parallel. I'm not sure. Or maybe they weren't actually running in parallel. They are just so short. Actually, let's try this one. So GitHub Actions Perl, it's called. So let's go to the command line and work GitHub Actions Parallel. And in the GitHub workflow matrix, let's put here 30 seconds. So we'll see, and I can even put here more numbers. Okay, just I need to type in these things. Make it nicer. Okay. Let's have 20. Git add and git CI more. And I'm pushing it out. Okay. So this is the trigger. And now if we go and look at it, you'll see that there are the two things. They are both waiting. I click on this one. You will see that like all of them seem to get started immediately, and then but maybe some of them are waiting. Actually, maybe this means they are queued. It's running. This one. They all seem to be running at the same time. I'm not really sure why. Okay. But now they are waiting basically 30 seconds, and then they will end. Anyway, this way you can experiment with it. That's how I experiment with quite a lot with GitHub Actions. Okay, here it is that I was looking for earlier, the runs on field. So here you can say on what kind of operating system you want your jobs to run. We had this Ubuntu latest and Windows latest and macOS latest. These are basically called the runners. And my phone is beeping all the time. I'm not sure why, but I don't need to care about it for now. Okay, so you have the description of exactly what machines these are, what of the powers, and there you have a lot more. So you can be more specific, not just saying Ubuntu latest. You can say you would like to Ubuntu whatever, and then with all the others. Okay, and you can actually set up your own. You can have any machine on a virtual private server and then configure it as to be a runner. Obviously, then you have to pay for whatever server you are running, because now you're running your own virtual private server in, I don't know, I guess GCP or whatever place you can run. It just has to, they somehow have to communicate with each other. Okay, so that's more information about that. Okay, that's not very interesting. Let's go back to the Perl part, because that's going to be the more interesting one for you. Let me close this one and this one. And so let's go over a couple of examples with Perl. So this is going to be the first one, which is just some simple Perl example. Here it has a name. Fine, nothing special. The trigger is on push and on pull request. Okay, nothing very special. And here is the job. So it's running on an Ubuntu machine. It has this strategy of running. And you can see we defined here the Perl version variable and set it to 530. So this is an older version of all this configuration. And it also have 532 and latest configured. You can put here any names here. And as you could see in the earlier one, I put them in the list of values. I put them in square brackets. You can do that. You can put them in this YAML-ish way, whichever you prefer. Then, and this is an interesting, we are going to use a container. Okay, so in the examples earlier, all of our jobs were running on it's not bare metal actually, so it's not really on metal because they are all using some virtual private server to run that. So it's not really on the machine, but those were thought of machines. Now this one is going to be a container inside that Linux machine. So this is the Docker container, and this is coming from the Perl Docker Perl tester. This is the name of the container. I think actually I have a link here. No, yeah, this is was that the Perl tester? Yeah, okay, so you can go to the hub, the Docker hub, and I'm not sure why I don't have the link, but I should have. And this is the image. Where is it? Just, I don't know, before so I think this is this. Okay, what am I doing incorrectly? I don't know. This is supposed to be the link. Okay, it's the link here. I thought that I checked it just before the presentation. Okay, we found it. Good. So this is the image that is being used there. You can see whatever. So it was designed, this image was created, so you can all kind of testing libraries, Perl testing libraries already installed, and various common libraries. So when you're running your test, it has a speed, it's much faster because all of these things are already installed. You don't have to install any of these. Okay, so I get back. So this is basically setting up which image to use. Now, this is just setting up the image, and then this sets the version of the image. And this one is, we are taking the value from the matrix. So if we had enabled these several ones, then it would run in parallel, basically, 2 or 3 or more versions of Perl, the containers, Docker containers, and each one has different version of Perl. The name, we also have the same Perl version printed out, so you will see the result of this. And that's it so far. So if we go to the actions, you will see that it has only one now because I enabled only one. But we can try to look at this one. So it's called GitHub Actions Perl Docker. Let's try to, yep, okay. GitHub workflows. Let's enable another two more. Git add. And I'm going to push it out. Okay, and then it starts running, so we can see what's going on. Okay, I'm not clicking on anything. I hope that it will, yeah, it updates without me clicking on anything. Now this is running or waiting to run. And as you can see, it has 3 jobs here because the 3 versions, each one of them has its name. And then you can see that it's doing whatever needs to be done. Let's go on. While it's working, let's go on. So this is how we set up what container to use. Then the first thing that we need to do that we didn't do earlier is check out our source code, because by default, you don't have your source code on this machine. So this command will clone your repository, or at least the last version of the most recent version of your repository, onto this machine, in this case, into this container. So you have your source code there. And then because it's a makefile, it's a Perl module package, whatever distribution that uses Perl makefile PL, we are using the cpan-m to install all the dependencies, and I'm using the no test, so it will be faster. Then we run Perl makefile, make and make test. So the default things that you would run in order to run your tests. And here we even have another step. So far, this is basically cloning the repository, installing the dependencies, and then setting up everything and running the tests. We also have another step, which will install again all the dependencies, and it also installs a couple of more of the dependencies. Okay, I think actually you don't need it on this one because they are there, but for whatever reason I have them here. Okay, so this one I'm going to install several more of the dependencies, and then I turn on the release testing environment variable and run the tests again. So maybe it could be improved, this one, but basically, you know that some of the developers set some of the tests to be only executed when this flag this environment variable is true, and this is what we are doing, running those tests. But these two steps depend on each other because one comes after the other. So if the first one fails, then the second won't even run. Okay, so meaning that if something that in the real thing, in the real code, in the real test, something fails, then we don't even run all these extra tests. Now, you might not want to this way, you might want it a different way. It's up to you. Okay, you could also test them in parallel, setting up two separate jobs, and then you would run all this in parallel. Okay, I guess this we did. Let's get back to the So now they ran on all three. There's not much in this case, so in this project, so you can see that everything passes. Okay, I won't go. Okay, actually, I can go look at them. Probably I don't have much to say. I don't need to say a lot, but whatever I have here, a few examples. So this one, on every push, every pull request, the workflow display allows one person to run the tests, run the jobs, because these are not definitely tests, from the UI or GitHub Actions. Normally you can't. You can only rerun something. You can't initiate a new one. But if you have this flag, then it means that you can use the UI as well to start it. This is the scheduled jobs which are commented out here. Here we are setting up the runner, 3 different runners. So in the matrix, we have the runner environment variable. We have the Perl, not environment variable, the Perl variable, and we also have an exclude statement. So basically, this without the exclude, this would run 3 times 2 versions, okay, jobs. So it would run Perl 530 and 536 on each one of these. But I think when I created this, there was no Perl 536 on Windows. So I set this exclude, which would mean that only 5 versions are running. And then here we select on which one to run. So this is dynamic now. We are using this action, and I'm going to say a word about this. We are using here a different tool to set up Perl. This is also, I'll say about it a few things in a few minutes. And this has some variables. So this thing has variables, and it knows which version of, or it can know which version of Perl to set up. You just have to provide the Perl version number, which comes from the matrix here as well. Okay, and this one can also both use the strawberry Perl, and I think the default would be the active state Perl. I'm not sure what the default here. And then the rest seems to be the same. It's just installing with cpan-m and running things here, setting up some environment variable. So let's talk a little bit about these two things, this one and this one. This is, okay, and before that, one other thing, which is a confusion, I think, made by GitHub, and it confused me for a long time.
what is a workflow, and because they are using the word both workflow and actions. So for the whole thing, here at the top, they call it actions. But what you have is a folder called workflows, and in there you have these files which are describing workflows. So in this level, there are synonyms, actions and workflows. But then each workflow, beyond just, besides running commands like Perl or cpan-m, okay, just shell commands, they can also use external, and these are also called GitHub actions. So one of them is this one, and the other one that we are using is this one. This is also called in the actions project, so it's also even further confusing. Let me copy this one. This is basically a GitHub repository called actions, checkout, and so this is a GitHub repository that has some instructions in it that can run on a GitHub inside a GitHub workflow. So these pieces of that can be used in a workflow are also called GitHub actions. Both those that are under the actions name, this comes from GitHub, and also the ones that are owned by some other people. So this one owned by, I don't know who. Okay. So you can use these actions, they are called actions, inside your workflows. The common ones, they are all under the actions user or organization provided by GitHub, and then tons of other ones. Now, this one, and let me get back to here because to clear it up. So here, this includes the name of the action, which is the name of the repository, name of the owner, and the name of the repository, and the version number that you are using. And this one actually is outdated. So this version number here after the @ mark can be a SHA, or can be a branch, or can be a tag. Okay? Now, that should be already 4, but I guess when I created that example, then 3 was the most up-to-date version. So if I go back, was this example? I don't even remember anymore. Okay, it's called GitHub Actions Perl Makefile. No, this is another one. Okay, I won't update it this way. Okay, so this one is using version 3, and because of that, it will give me some warning, I think, because version 4 is the most recent one. Of course, I could also say 4.1.7 if I want to be more specific, but then it won't be the latest version 4. It will be the 4.1.7 even a year from now. I think there is no just, oh, actually, yes, I think if you don't set this, so someone asked if there is a latest here. I don't think there is a latest, but if you don't use a version number here, just without the @ I think then it will pick up the latest version, which probably is not a good idea, because then sort of you're automatically getting the most updates, and it might not be, it might break your jobs. Okay, so probably that's not the good idea. I think that's not a recommended thing. The more recommended is to set some version number with just one number. Okay, and then time to time you update this from time to time. Okay, I think that's it. Right, and the other one. So this is a very Perl specific, and here you can also use, I guess, various tags, and probably that's also outdated already. No, it's version 1 is the latest. Okay, and then you can read, of course, here you can read tons of things, how to use it, and what does it provide, and so on. Okay, and this is just more code, so whatever. Right. Any other questions here? Well, I've been talking almost an hour now.
and still have lots of things to show. Okay, so very similar for diskzilla or build.pl. Obviously, the commands will be slightly different, not Perl makefile.pl, but something else. But the rest is quite similar. GitHub Actions examples, what is this? Okay, so this is not that deep, or I won't have to go into. This is just a page on the CodeMaven website with links to various of my GitHub repositories with examples, the three versions that you already saw, and then very specific ones for MySQL or PostgreSQL. So these were experiments I made, but it's nice because they are already running, and then you can copy from their examples if you'd like to see how these things work. So that's why. And now let's go to the DBD-PG, because that's a very interesting one, I think. Well, yeah, it's interesting. I'll have to make that. Where is the repository? So this is the page of the metacpan of DBD-PG. This is the link to its repository. And here is the workflow. Okay, so or actions. So what does it have? It has a name, fine. It has a trigger on push and pull request and on workflow dispatch, and this commented out. This is just my signature that I have this commented out. There is a strategy running on 2 different versions of Perl and 3 different versions of Postgres. Okay, it's basically arbitrary what I picked here. So this pull, I sent this pull request and they added it, and since then I guess it wasn't configured a lot. It can be updated with other versions of Perl and so on. And here is the interesting part. So this, in order for this to run, you also have to have a Postgres server running. So GitHub, I'm keep clicking on it, and then it switches place. So you can set up services, as many as you like. You only need to, then you give it a name. This is arbitrary, you pick the name, and then you say basically what Docker image to run. So it's nothing else, just running some Docker image, a Docker container basically. So running a Docker container based on any Docker image. And by default, it will go to the Docker hub, but probably, I guess, I haven't tried, I think, you can use also other Docker registries. And so you can run any service. This specifically, if you read the documentation, also needs set up these these things, and you also need to configure these options. So from my point of view, this is all magic. Okay, it was in the documentation. I read it and copy pasted, and it works. Okay, these are the 3 things that sort of you need to set up both on the server side and also later on in the client. Okay, so you will be able to use it. This is setting up the name of the database, the username, and the password. Okay, and it doesn't matter that it's free text because it's only running for the duration of the tests, and only I guess it only has access internally, so it doesn't really matter. So this is how I tell GitHub Actions to start a Docker service, a Docker container with some service, and then here this is my code. It's going to be running in a container, which is just the very plain Perl image, Docker image. It checks out my code. Again, this is old, so it's v4 now. I just print out the version of Perl, doesn't really matter. I don't remember why. I installed some stuff on it. That's because it's Ubuntu based, so I can use apt-get. Okay. Then I installed the Perl needs. Let me get to the point where it's really interesting. And here is where I'm running the tests. So you can see that I have to configure. This is how the DBD-PG requires it. It requires this DBI DSN to contain the connection string. Okay.
and then the password and the user to connect to the database. So this will allow me to run the tests with these environment variables. So here we run just make test. So these ones don't need these variables. The make test only needs. So it was limited to test one. And so you can go now to the actions folder, not folder, whatever on top here. And I guess, I don't know how can we see it. You can see the 6 running them, and then let's pick this one. Run tests. Okay, and you can see that it's running all the tests, not just the ones that can be executed without a Postgres server. So it's extremely useful because you can run. Now, you can't really expect it from the cpan testers. I don't know if they have set it up, and especially if you're private code, then obviously that won't work. I guess that's. I mean, I'm more than an hour, so probably also want to end this already. There are a couple of more examples here that might be interesting. That's it. Couple of more things. What is this? I don't remember. Oh, yeah. So this is the documentation of in the marketplace of how to. This is the GitHub Actions marketplace or workflows marketplace. So you can have all kind of things. This is the description of that specific action with all kind of details. So it can be very useful. I think that's it for now. I have this is just a Perl OS matrix. These are not very interesting. Okay, so the Perl planetarium that I mentioned at the beginning, I think I'm going to delay it for the next meeting because that actually belongs there. That's one of the examples of using the GitHub Actions not to test your code, but to collect the data and generate a website. So that's basically a static site generator with some very specific data. We're going to see that in the next meeting. If you have any questions before I stop the video, then ask it now. If not, then I guess I'm going to stop the recording. And then you can still stay around and ask more questions or try it on your own projects, and then I can help it live. I just have to check my phone. So thank you for being here. It helps me a lot to have audience. It's much nicer to speak to an audience, even if I can't see you, but you have some interactions. So thank you. And all the people who are watching the YouTube, thank you also. And please make sure to thumb up the video and follow the channel. And thank you very much. See you next time.